Okay, let's talk a little bit about functions. Okay, in fact, function is a very important feature for almost all computer language because it can. The basic idea is to group in uh, a set of statement and put a name to represent this group of statement. And the best thing about it is that anytime in the future you want to execute the same group of statement, you can just call in, okay? You can just do in the call in this function. And by calling this function, computer will execute this group of statement, okay, one more time. And you call twice, it will execute twice. You call three times, it will execute three times. You put a function within a for loop, it will execute the number of times the for loop will be executed. Okay, so so this is a very important feature for almost all language, almost all computer language. C is even more powerful, okay, with some additional functionality called recursive. Okay, some language do not support recursive, but C support recursive. Okay, uh, we will talk about recursive later. Let's introduce the format, the syntax of function for C first. Okay. Uh, Function is a serial statement, and we group together and give it a name. Okay, so this name is very important. Uh, the way you give it a name is following the rule I give it identifier. Okay, so function name is also identifier. You follow the rule. Uh, the naming convention is the same as the naming convention available. So you should start with underline or big letter or small letter, and then numerical number. Okay, is also okay, but you cannot start with a number. Okay, so four times. Okay, and this is not good. Okay, this cannot be used as identifier. Um, each function, okay, we should define, we should distinguish between function declaration. Declare, function declare, and a function define. Okay, to declare a function and to define a function, this is a basically difference. Okay, it's very different. Okay, so now let's see this. Let's see a very small example. Okay, we just type it. Okay, it's uh, average. Okay, so this in C we can shoot, we screw up completely. Okay, we can define a function called average. Okay, average, average. And this function would take two arguments. Okay, and the first argument is a double, A, and the second argument is also a double. Oops. Called B. Okay, and then this function average, after its computation, it will return a value. Okay, a single value, one value at most. Okay, you can return nothing by putting void before the function name. So this average is a function name, and then small parentheses, this parenthesis will contain the argument. Okay, in fact, the argument you can treat it as a variable. Okay, so A is also play a role of variable. B is also play a role of variable within this variable function, within this average function. But in here, we are going to return a double data type after the computational average. Okay, so the computational average is we have a double. We call it result. In here we define a variable called result, and the result is the variable result is shooting a compute of two values. One is A and the other is B. And divided by 2.0. And because of the precedent rule of C, we should put parentheses before to enclose A plus B. And then we return double. Okay, so no, return result, not double. Okay, double is the data type of result. Okay, now in here I want to emphasize. Okay, I want to emphasize A can be treated as a variable of average. B can be treated as a variable of average. Result is a variable of average. And A, B, and a result is called a local variable. Of this function average. Okay, it's called local variable. The meaning of local variable means that only average, only this function, this average function can access this variable. So let's come back to this example. I just say A is local to average, B is local to average, result is local to average. In here, in main, can we use something like print F %D backslash and print A? Can we do this? Can we do this? The answer is no. Because this A is local to average. putting A in main is go beyond the scope of average because this pair of big bracket is the scope of average, and A, B, and result is local to average. So not only you cannot use A, you cannot use result either. Okay? Because you can see a small red line here. It means C compiler cannot recognize result in main function because result is available local to average. So it can only the function of average can access result variable and the A variable and the B variable. Okay? AB not only play the role of variable, but also play the role of functional argument. What is functional argument? It's some kind of window that connect the calling function and the function being called. Okay? So I have to mention in C, it's very important in C. It's a very important nature or feature of C. The function of C is called by value. Okay? It's called by value. What do we mean by call by value? Is that when we call average, how to call average is in other function. Okay? In other function, you put in the name of the function average. So what we can do is in main we can get f percentage LF and the space percentage LF, and we are going to take two values. One is double x and a double y. So we ampersand x. We are going to take a floating point value and say into x, and take a second floating point value or a value with can have fractional part into y. Okay, and then what we are going to do is we in here we define the third variable called answer. Okay, now we can answer equal to average, and we put in x and y. So in here, this line, we get two values, x and y, from my keyboard, and then the value of x put into the first argument of average, and the value of y put into the second argument of average. What I mean by call by value is that we transmit the value to the function being called, to the callist function. Which is average here. Okay, the average here is being called. Okay, now what we mean by call by value? In main, we have a x and y. Let me draw the memory map. Okay, imagine this is your memory space. This is x, which is belong to function main. And this is the memory space for y, which is belong to function main. Now we have a okay, in another space. A variable is belong to average. B variable is belong to average. And we also have a variable called result, which belong to average. And in main, we have another variable called answer. Okay, and each one of them is double. Okay, they are all double. The size of this each space for each variable are sufficient, are as big as the double data type required. Okay, now in here, every program starting from the percentage f plus the average of percentage f and the percentage f is percentage f. So in here we first number we print x, second number we print y, third number we print answer. Okay. Let's take out this comment here. So in main, we have three variables, one called x, one called y, and the last one called answer. This three variable is belong to main. This three variable is local variable. It can only be used by the function of main. Okay, this three variable cannot be used by average. Okay, we have two functions here. One is average, one is main. By the way, I should mention is that in C we have independent group. We define this function independently with this main function. In a long time ago, I mentioned main is a function. And in C program, there will be only one main, okay, function, only main function, only one main function. And there has to be one main function. In your C program, you don't have a main function, that your C program cannot be run, cannot be executed. So unique main function is necessary. Okay? So main is a function. And the way C to do it is treat it as an independent entity. It's independent function. Okay? It's independent from the average function. And average function is independent from main function. Okay? They cannot put together, which means you cannot define a function within another function. Okay? A function cannot belong to another function. Okay? So this is independent function called average. This is independent function called mean. However, it's perfectly legal to call for function to call another function. This action is called calling. Okay, average. Just like you ask your friend to help you do something. Okay, this is calling the average, the service of average. Okay, average is the name of this function. So you call it by function's name. Now we can execute this. Okay, now when we execute, let me draw this whiteboard first. When you execute a C function, it's starting from main function, starting from main, and starting from the first statement of the let bit bracket, the first statement, and one by one to execute. And once a main function see calling another function's name called average, the control of the program flow will go to average. The control of the program execution will go to average. At the same time, okay, let me go back a little bit. In main, we have scanf, so we can, by execute scanf, we put a value of 10.0 to x. We put a value of 15.0 to y. Now, by calling average, we take the value of x, which is 10.0, to the first argument of average, a. So we copy the value 10.0 and put it into a argument 10.0, and y is the second value, second argument, so value. So we have a y, and now y will pass, the value of y will pass to b. So b will take this 15 and say into here. Once we done this, this is called call by value. Okay, we by passing the value, okay, available. So 10 will copy to here, 15 will copy to here. Before average, before this function start to execute, we already got value for a, which is originally the value of x. We already got value of b, which is original value of y. Okay? So conceptually, we can see out this way is a is equal to x. Okay? But x belong to y, a belong to average, b is equal to y is belong to mean, b belong to average. These two kind of action is done before average actually begin. Okay, once we got the value for a and then the value for b, and then we go into average function. We declare a local variable called result, and then we do this computation because we have a's value and the b's value. We sum it together and divide by 2. we come up with a result, okay, which is the average of these two values. Now, we have a last sentence, last statement for average is return result. By execute returning result is returning the value of result, and result is double. Okay, result is double variable, and we return result which is perfectly match with this functional prototype. This is the first line is called function prototype. Okay, which include the function name. Should include a function prototype should include what? Function name and the parentheses. And the parentheses include the function, the argument data type, which is double, and the return data type, which is double. Okay, this is called functional prototype. And in C, this is very important. Okay, in C, this functional prototype is very important because C is a very rigid language, and you do a lot of checking for programmer's error. Okay, once you call this function, this prototype is not matched, C compiler will give you warning. Okay, so it's very time rigid language. Okay, it's very time rigid language. Okay, so come back to this example that we return result, and this result, the value will be returned by this average function. Then this average function will return the value of result, which is here. After return, the value will save into answer. Okay, so in main function, we got the result of average and save into the variable called answer. Okay, and we print the answer in this printf. So let's compile and let's execute. Expecting me to put into number with fraction. Okay, one is 10.0, one is 15.0, and we can see the result is the average of 10.0 and the 15.0 is 12.5. Okay, now, so come back to the whiteboard. Once the average calculates, okay, let's roll back a little bit to this whiteboard. Once in the function of average, sum these two, 10 and 15, and divided by 2, we get 12.5. Okay, and then at the end of the average function, we return 12.5. And once it returns 12.5, the variable answer will get the result here is 12.5. And in the printf of main function, we will print this 10, this 15, this 12.5. Okay. So this is a complete example of average. But maybe this example is the same as the PowerPoint provided by the author. Maybe we can extend it a little bit. There's no limitation of how many arguments you define in a variable. So we define the third one, call it B. And we going to calculate the average of 3 double, okay? Divided by 3, okay? And here we are going to get 3 double, okay? And LF and XYZ, okay? Now we put 3 argument, because in average we have a 3 argument. When we call the function, we has to be 3 value. Okay. Now the average, the answer, okay, the same. So the average of x value and the percentage f is, okay. So we print x, y, z and the answer. So we kind of calculate the average of 3 value, okay? 3 double value. Now, so we put 10.0, 30.0, and 20.0. Okay, everybody knows the answer. Okay, the average of 10, 30, 20 is 20. Okay, so let me say this example before we come to the next feature that I'd like to introduce. Okay, now we call it EX12-04A. Now, what I'm going to do, what I'm going to say is that we emphasize what I just mentioned. This A belong to average. This B belong to this average. This C belong to average. This result belong to this average. Okay? So in main function, can we change x into A? Can we use A again? This A, this variable name is identical to this A. And B and Y we change to B. And X we also change to C. And the answer we change to result. Can we do this? The answer is yes. You will get identical result. Why? Because what I just called this variable a local variable. It's local to its function. A, B, C, and the result. Okay? We have the same name in both functions. We have A in average. We have also an A in main. We have a result in main. We also have a result in average. But even they are the same name, but their storage location, okay, the memory space occupied by this identical name variable are different location. As I mentioned, this figure, we call this X, we change it into A, this answer we change into result. In fact, we have C, we just skip it. A is belong to main, B is belong to main, result is belong to main. And what I'm going to say is this main, this A belong to main, and this A belong to average. They occupy different location. Even they have identical name called A, but they are different memory location. By changing the value of one location does not affect the value of the other location, even they are the same name. Okay? And this is a very nice feature of local variable because okay, suppose you are doing a large project, you have a team of programmers, and each one write its own program. We have a big project, and everyone write a several function or several functionality. We can divide a big job into a small job, and each small job for one person take the responsibility to do. So if I use a variable A in my function, in the function that I design, and you also use variable A in your function that you design, these two variables should be different memory location. Okay? On the other hand, suppose my function called A and your function also variable also called A, and they are saved in the identical location. In my function, I change the value of A, and then your function, the variable A, the value also got changed. So there's no independent. Is interconnected. Is overly infect each other, overly affect each other's program, each other's function. So the function you load, you using variable A, and the function I load, I use a local variable A. It's all right. But in my function, I change the value of A. Will not have any impact on the variable A that in your function use. Okay, use in your function. Okay, so it's a very nice feature. Okay, local variable. I have to emphasize. I cannot emphasize this about the concept of local variable. Okay, so even two different functions using the same variable name, they are perfectly different. They are totally different because they occupy different memory location. Okay, so let's come back and take an experiment of this program. This program average have A, B, C, and a result. And main program have A, B, C, and a result. And this A, B, C, and result belong to main, which will not have any impact on the A, B, C, and the result to the of average. Okay, they are independent location. So I did not change the logic of the program. The only thing I do is I make the variable of two functions the same, but we rebuild. Okay, we did not, this typo, we did not change B. So they build a function, they build a program, and then we run this again. So we put in 10.0 and 30.0 and 20.0, and the result is identical to the previous version of the result. So I hope you understand what I'm going to emphasize here is the local variable. Okay? So let's say this version of program. EX12 dash 04B. Okay? Now, in this program, what we did is we have the program structure is like this. We have average, okay, and return double. And what should be done in average is right here. And then after this is called function definition. We define a function here, which is complete. The function is completely defined here. And then we have a main. Okay? Main here. And this block of the program, we define main. And in main, we call in function average. We are call the function average. Stupid. Okay, we call the function average here. We define an average function and then call the average function, or then use the average function. And the program can be smoothly run, can be normally execution. Now, as I mentioned, each function is an independent identity. Supposedly we copy this independent body of average function to the button of main function. Are we okay by doing this? The answer is no. Why? Because C compiler was starting from the first line and the 9 by 9 to compile this .C program. When C compiler see this line, compiler get confused. Why get confused? Because compiler don't know what is the identified average. Average is what? What is average? Compiler do not know anything. But in the previous version, we define the average first. In the previous version, we define average first. So compiler see the average first. Average is compiler know average is a function and takes 3 double argument and return double. So it perfectly know. And then down here, it call the average. So compiler know what is average. And so compiler is happy and keep going and finish the compiler's job. But if you move this average down to the below main function, the compiler compile this file 9 by 9 by 9, and once it encounter this average, it's confused. So it gives you warning, okay? And this is not good. So normally, people will put main function at the top of the .c file. And the function you're going to call in the bottom at the later portion of the .c file. So one way to get around this situation is using function declaration. How to declare a function and declare the function before using the function, okay? So we put this prototype 9, okay, which is normally the first line of the function, and put it here, okay? Remember, you have to put in semicolon at the end. Please do remember, put a semicolon at the end. This is called function declaration. Declare the function, but not define the function. Because what the function or average will do is not mention anything here. What in the function declaration is only talking about the type of argument and the type of the data it will be returned. Okay? And how detailed the average function will do is not mentioned here. As I just say, C is a type rigid language. So it will check the first parameter has to be double, the second has to be double, the third has to be double, and the return has to be double. Okay? When you call in this function here. Okay? So supposedly one of these arguments is not double, it will give you warning message. The result you will get from this function is not double, it will give you warning message. It will check for checking, it will do the checking for you. Okay? Which is a nice feature of C. And that's part of the reason C is such a long life. Okay? It's more than, I guess, 40 years old. Okay? It's still using. Now, so once you put in this functional declaration and you compile it again. Okay, so no warning message, and the compiler success, and we put in 10.0, 30.0, 20.0. Okay, you get the same result. Okay, so up to now, you should know what is function definition and what is function declaration. Okay. To summarize a little bit, is that this is functional definition. This box, okay, the red line box, okay, this functional definition include the prototype, okay, and the big bracket of detailed statement that will be grouped together. When this function is called, this statement will be executed. This is functional definition. And this part, the first line, with the additional semicolon. This is important, okay? Semicolon. It defines the function declare. Functional declaration. Okay, it just declares the function. Okay, it does not detailedly describe what the function will do. It just the prototype of the function. Okay, so let's take 10-minute break now.